Hello everyone. In this video, I'll discuss the question 9 in the homework 8. Let's see the description of the problem. In this problem, we are asked to show that if x1, x2 to infinity is a Markov chain, then it is statistically determined by its second-order probability methods that Px I equals xi and xj equals xj for any ij equals 1 to infinity. We know that in a Markov chain, the future state of the process depends only on the current state, and it's independent of the past states. So this property is known as the Markov property, or the memoryless of property. The process moves from one state to another according to transition probabilities, which specify the likelihood of transitioning from one state to another. And from the definition, we already know what we need to prove is correct. And now let's give a more detailed proof. So then we know that the probability of xn equals xn, xn minus 1 equals xn minus 1, to x1 equals x1. It equals the probability of xn equals xn given that xn minus 1 equals xn minus 1, to x1 equals 1. And times the probability of xn minus 1 equals xn minus 1, xn minus 2 to equals xn minus 2 to x1 equals x1. And we do it many times until we got the equation that it equals probability of xn equals xn given xn minus 1 equals xn minus 1 times the probability of xn minus 1 equals xn minus 1 given xn minus 2 equals xn minus 2, and the times until times the probability of x2 equals x2 given x1 equals x1 times the probability of x1 equals x1. And we know that the probability of xi equals xi, it equals the sum from negative infinity to the positive infinity, that the probability of xi equals xi and the xj equals k for any constant j. And the probability of xi equals xi times given that xi minus 1 equals xi minus 1, it equals the probability of xi equals xi and xi minus 1 equals xi minus 1 over the probability of xi minus 1 equals xi minus 1. So we see that the upper half of the is we see that this upper half is the second order probability methods, and the lower half is determined by the second order probability methods. So based on the equation above, we know that what we need to do is proved.